Okay, this is going to be a postmortem of Project M. It's a Mummy game, and it's a VR project in Unreal 4 using the stock audio engine. So what I wanted to show is the basics of the Unreal audio engine and how I use VR to do things while it's all fresh in my brain post-crunch. So my brain's a little scrambled, but at least I'm still in everything, so I can explain how everything worked. So, VR in general works pretty much like regular audio, but the first thing you have to be aware of is in the plugins, you need to enable the Oculus audio plugin. That does the HRTF, that does the spatialization. It allows you to do attenuations that are HRTF based. Without that on, it won't have the head related transfer function enabled. So once you enable that, you just save your project, it enables it, it's pretty easy, turns it all on. But then you need to enable it in your attenuations. So in each attenuation, you can now, once you enable that, turn on HRTF as your spatialization algorithm for anything that should feel as though you're actually there in person. So most everything used HRTF. I think it's a little more processor intensive, don't quote me on that one. So just use it on the things that it seems to matter with. I'll start by going over the sound classes, the overall mixer. So sound classes are your mix buses for anyone unfamiliar with it. Generally, it's best to have a master class that splits out into an SFX class, splits out into a music class, splits out into a VO class. And we also had these other things for LFE and haptics for special effects. Ignore those that didn't end up being used. So in the SFX bus, we have this group of things. And those are all just sub-buses, some with sub-buses of the sub-buses to control mixing and do smooth ducking. So this is the overall structure. I'll just kind of go through it as an overview, and then we'll go over it one by one. So I broke it out into NPC weapons versus player weapon. Player weapon needed special ducking because, you know, it's the thing that connects to the player. So I left it fairly loud in the mix. This had a unique dynamic of never having to reload and being able to fire infinitely. So I had to keep it fairly low in the mix because, you know, find that healthy balance where it still felt like you're firing a gun, but not overpowering the mix, which ended up being 0.2. And as a limited asset, a 0.2 in the mixer, I think, puts it around -10 in the mix. The game ended up being -18 LUFS. I'll talk about that later. But so we have all these different buses, the characters for character sounds, environment, which is good to separate out because you don't want to duck environment sounds in VR because it needs to be immersive. You have to keep the player in it. So I didn't duck the environment as much as I normally would. I don't like ducking in general, but it's required at certain points. The helicopter sound was its own thing as well because I like to duck it. Anything I ducked differently and I wanted individual control, these were the things. Vehicles, again, I did heavier ducking on the vehicles because they weren't as important as the guns and the other undead in the game. Epic moments, which are very important because they had their own passive sound mixers, as I recall. Enemy focus moments. So here's an example of a ducker for anybody that hasn't seen a ducker in Unreal Engine. Whenever this receives a signal, will follow all these rules, and then it will do this passive sound mix modifier. That's your mix rule. That's things will happen. Whatever this says will happen whenever this receives signal while the event is occurring. So it's not sidechain based. It's not if it gets signal, it's just something's happening. So again, it can be ducking that's too severe, that's just on, even if it's not getting signal, it's just, so, you know, not the smoothest, not sidechain based, but when it gets this, it will do this sound mix modifier. What will it duck? Well, for that, you have to hit that search. You have to go into the sound mixes. You have to open up the dialog focus moment and take a look at the parameters, expound the sound class effects. Each one of these sound class effects will then be modified in the ways you tell it to. So the SC SFX player weapon, whenever the dialog focus moment bus gets signal, it will duck the player weapon to 0.9, and it does everything at the same initial delay So it'll wait a little bit, then it'll fade in 0.4 seconds, which felt like a smooth thing instead of being too obvious. It felt like a natural perception. Fade out, meaning it will return back to 1.0 after 1.1 seconds. So it does all these modifications. To prevent ducking from being too extreme and too obvious, I did every single sub bus separately to get a very smooth, natural sounding duck that's more perceptual than an obvious, well, we can't hear the dialogue, duck everything. So I hate that kind of ducking, and that's how you fight that. So each one of these does this whenever that gets signal. So that's how you set up ducking. You go in here, click the plus, add in your sound mix, define your sound mix as in these parameters, how much to turn it down. 0.8 will turn it down to 0.8, or essentially if it was at 1.0, it will make it 0.8, and it will multiply depending on if it's quieter than that. Pitch, same thing. Apply to children if it's children, and voice center channel volume adjuster, I put those all to 0 because I didn't want any center channel volume adjustment. Okay, that's the basics of the mixer for the sound effects. The music, I had one that was ducked and one that was unducked. I had two different layers, one that had the low end energy and one that had the tension high end. And I only ducked the low end energy so the tension remained, but it didn't feel cluttered with the drum layer and the low mid layer. So I had those split out so I could duck on the duct. The music stinger, that was just a separate music bus, so I could have stingers on a different thing. The dialogue focus moment, there's another one that ducks, and that ducks by doing diafocus moment. So go figure, guess what that does? Yeah, it does those ducking settings. And the VO game over, music ducking all, which again is another passive mix modifier that will, as you guessed, take each one of these and turn down the music to 0.5 if at 1.0, and it will do it 0.05 seconds. It will wait, and then it will fade in for 3 seconds, fade out for 10 seconds. This was more of an extreme, let's make sure it's audible, it's at the end of the game, so it was a hard mix change, supposed to be obvious. That's the basics of it. So that is what sound classes are. That's how you do ducking. That's how you do mix modifications. As far as sound effects go, I ended up putting them into this directory right here. And you can see all the sound effects for the game right here. And I just left the cues and the waves in the same directory, which for me works because it's really easy to, if you just type in cue into this filter, it'll filter only cues while you're clicking around. And if you type wave, it'll only show the sound waves. So I don't mind having them in the same directory. It doesn't clutter it up for me because of that trick. And I'd prefer to have it that way than have something that says cues and source and this and that. I like it all in one place. It actually made it easier for me. So in Unreal, you probably know everything has to be 44, 116-bit. Channels, that's different. Generally mono. Stereo does give you spread, and I use it quite a bit in VR because stereo allows in the attenuations to have a spread, but I'll get into that in a minute. So some sounds, when you want them to be wider in VR, you're going to want them to be stereo. So make those decisions as appropriate. Let's go ahead and look at a sound. The Hello Rotor and Sub are kind of 2D sounds. Go to the engine loop. I had a Doppler on these, straight up 1.0 Doppler. They don't move super fast. Doppler in the Unreal Engine, if it's going really fast, this 1.0 will be extreme. It'll be that almost whoosh by kind of thing. But for a slow moving vehicle, 1.0 sounded just fine. Added a little movement and pitch to the sound. I'm told you're not supposed to do looping in this way, that it does introduce clicks and pops. I learned that later, that actually on the sound wave itself, you're supposed to modify it to be looping, and that is where you're supposed to control that logic. Looping is supposed to be for a logic in the sound cue, so I set this one up wrong, but you never heard it and it sounded fine, so I mean, you know, life goes on. Volume multiplier. Let's talk about all the parameters of a general sound cue, and then we'll go into a more complex sound cue. First things first, you want to set your attenuations, and I didn't override it. This is how you override it if you just want it on this. I'm using a share set, to use wise terminology, meaning an attenuation in this attenuations folder. That's just where I put them. They could be anywhere. So I made one called vehicle attenuations. Let's open that up, and we'll start at attenuations. So this was an HRTF because I wanted it to feel like you're there with your head. Again, Oculus Spatializer, Spatialization, HRTF. I did linear fall off, which felt better for something that's far away that you never, but even if you get close to it, for a vehicle, it felt better because you didn't want it to go real high and real. It was more of a gradual linear fall off. Felt fine. Sphere is fine. Radius in the helicopter game, just so you can see the settings. 6500 was really far away, but with a linear fall off, it felt natural as it faded into nothingness. The 3D stereo spread, as I said, will take the two channel sounds, and as I understand it and heard it, will spread them out 129 away from each other. So you can actually get that stereo information instead of folding it down to a mono. That way, it's a little bit wider than a mono sound. It's just at the same point. It's got this little width to it. And you can do much, much bigger than that, and I believe that's Unreal Units, how far it's spread. LPF, I added an LPF just to make it more natural. I wish they had an HPF parameter. We'll have to ask for that in the future. Again, the min is when it starts applying, and it starts at, I set it to 19K, and once it hits 5600 distance, it's going to be 8800 low pass frequency, which isn't extreme at all. It just helps kill some of that little too close high end. Felt natural here on the vehicles. Listener focus is the biggest one. This is a huge VR tip. Focus allows you to mix based on what you're looking at, what's within your field of view, and what's out of your field of view. So if something's in your view, you can say, hey, you know what? Perceptually, I want to turn that up because I'm looking at it. And I want it to feel closer because I'm looking at it. And everything that I'm not paying attention to in a cluttered game with a 360 view, I want to turn it down and I want to low pass it, or I want to do stuff. That's what you do here. So this game got cluttered as hell. We had a ton of undead. Just constant battle. Constant stuff going on. And so the only way to bring focus in a crazy game that's in VR where you can look anywhere and do anything was to create focus in the mix using this and other sound mixing techniques. And it made a huge difference. So if you're doing VR, focus is going to be your best friend. Also using Robo Recall fairly often. So you turn it on, change your focus azimuth. 30 and 60 were actually pretty much the defaults. I think that's what it defaults to, and they work great. That's the, angle in degrees that it applies. So it just felt natural with the Oculus headset. I don't know about other headsets, whatever. 3060 is a good starting point. Now, not much is going on here with the vehicle itself. We're just reducing the volume when it's outside of your focus. So generally what I would do is find a good place in the mix for things without using focus. Get everything at a good level. And then, based on gameplay and what you want to be important, go in here and adjust focus to give clarity to the gameplay. That way you have the right levels and you know you need to either turn something up or down just based on that extra parameter. So this is polish after you do a good mix. So I just turned it down. Everything sounded great except when it was too busy and you weren't looking at them. So for these, I just turned them down when they're outside of that perceptual degree. Made a huge difference. I used that on quite a few parameters. The undead is a very good example of attenuations that have occlusion as well. So occlusion based on if they're visible through the helicopter or behind a tree or whatever. It'll apply a low pass and turn it down a little bit. And this also has a huge focus. And this stuff, when I say huge, this was very noticeable. Even these 1.2s and 0.8s, incredibly noticeable, made a huge difference in whether an intense combat situation is too cluttered, or just enough information to know there's an enemy over there while you're killing something over here, but you're paying attention to this thing over here. So these are some example parameters of how to use focus in Unreal Engine to accentuate what you're looking at by turning it up. The distance scale it's a little weird, the value wise. 0.82 means it will be that much closer. So if you make it 0.82, it will seem closer. And if you make it 1.1, it will seem that much further. And the same for priority scale. Nope, priority scale works like volume. So this one the values are almost opposite of what you think they'd be. 0.82 made it closer. With a volume, 1.2 would turn it up as you look at it. So again, one good example of an attenuation. And back to the cue itself. And then you have the sound, the volume multiplier. That's just turning things up and down on the individual cue itself. Sound class, that's where you assign it to the particular mix bus. And you can see I've done volume adjustments here later. And I close that. That's okay. I was looking at That's what I do for loops. And look at that. It's that easy to search. Concurrency, this one didn't have concurrency because you needed to hear the vehicles every single time. However, if you would look at the cue for concurrency, for anyone who doesn't know, is voice limiting. That's just what controls the voice limiting. You can do it per cue here by overriding concurrency, or you can use a share set of concurrencies, which I have right here. A very good example would be the NPC gun, where I did a very heavy concurrency limit of 18, and that's, sorry, not heavy, generous, like 18 sounds can play. It started sounding weird because there are, I think, 12 people firing, so if I did any less, it felt like it was cutting it off and not quite accurate enough. But it will prevent all of their bullets from playing all the time. Now, I did some that were much heavier. I think Undead has concurrencies of 30. No, that's not heavy. Spiders might be heavy. Yeah, spiders. So the spiders got hectic, and I did limiting on the animations too. It didn't matter. It wasn't enough. So even if you add silences into cues, and even if you pepper it so you think it'd be all right, sometimes there's too many actors on the screen. You just have to limit how many sounds can play. Or for CPU purposes, you need to cull it, or because the mix is just too crazy, you need to cull it. This is where you do your voice limiting. So I put stop furthest, then oldest. You could also do prevent new. Those are all your options. Volume scale for the older instances just helped a little bit, but the max count of 6 was fine here. This is where you set your concurrencies, and you can do that in share sets. I did that for groups of enemies, as you can see. And priority, this is for the concurrency. So you can set certain things in those concurrency groups to higher priority. So say you have voices and the deaths need to be a higher priority because it's the creature dying and it's more important than injured or idle or anything like that. You can control that with the priorities. So you'd set the really important one to 3, you'd set the normal one to 1, and the other one to 0.5. These values don't matter. It's just that higher is a higher priority. So they can be anything. It's just the higher the number, the higher the priority, and it'll kill the other sounds of lower priority first before getting to the high priority sounds in these concurrencies. Okay, that's a huge part of what was done here and why it was done and how these things work. I'll show you a couple more involved cues. We'll go into the weapon, player, cue. Let's just do cue. So we have the final shot. It looks like the team's altered a few things. So if everything's not as I expected, that's probably why. So we have a player gunfire. And we have the final shot. So the player gunfire, this gun was a really tricky one. It fires about 500 times. a second, I swear. It's got a crazy fire rate that's like a submachine gun, but it's an assault rifle. So we did tricks to get around that. And we had two different sounds playing. We had one with a tail and one without a tail that just had the initial pop. And ignore that reverb. That's going to be annoying, but in Unreal, it'll apply the reverb while you're in the scene. So I'm just going to turn down that because that's really annoying. Oh, that should show up there. I thought I had it in environment. The reverb setting. Oh, I thought I put that in environment. Where did I put environmental? There it is. It's in that environment. So let's just turn that gain to 0. I sure could turn it down to that should kill it. Now if we play that. All right. So you have that initial pop, and then you have an enveloper that controls the tail, and I had to do some adjustments in game after implementing it so it sounds more like that. And I'm not sure how that sounds. I can't hear that back, but between the combo, so I'm gonna play back the video and make sure this all sounds normal. I'm not sure the audio output I'm focusing on is this because I'm telling you what I'm doing, not trying to show you how good the game sounds. I'll do that later. The final shot, which is a similar one, had a different concurrency. So I had a concurrency on the player weapon itself, which was essential because if you can fire, 700 times 4, so you could only hear 2 total shots, meaning the beginning and a tail, the beginning and a tail at a time, and then it'll stop killing the oldest. That kept it feeling realistic while limiting the voices to 4. And then on the final shot, I did no limiting because you always want to hear the tail out of the final shot on the weapon release. Cool tricks on how to find things in the Unreal Engine. So we have that cue, and we have the weapon, and we have the final shot. We go, well, where is this used? Right-click, Reference Viewer. This is going to be a huge friend for you. This is where you find what waves it uses, where it points. So you look at your cue, whatever you clicked here. On the left is what's pointing to it, and on the right is what it's pointing to. So it uses waves. It uses waves. It points at concurrencies. It points at the mix. On the left, it points at the blueprint. Well, what's in the blueprint? Go figure. Right-click, Edit Asset. Search in the asset. We have Weapon, Player, and that should show up right there. And we can see where it is by double-clicking it into the event graph right here. Right-click, move around, left-click, select. And look at that, the actor location. So trigger input, win, can shoot, trigger press, condition, false, play the final shot. This would be the I've let go. And that's where your sound is referenced. Well, if you want to look at the other shot, you could find, let's do this one more time because that's just a nice trick. Right click, reference viewer. Look at that. Oh, it's also in BP bullet. Player gun, get SFX, event graph. Fantastic. Begin play, sound is fired, play gun fire. So that's how you can find where things are referenced in the blueprints. Sometimes they're as simple as this. Depends where they exist, but often you just have to go search. And if you wanted to find your blueprint in the content browser to see where it exists, you can find it just by hitting Find in CB. Very useful thing, Find in CB, content browser. That way you can go back and forth. So that is blueprints. That's where things were hooked up. That's how you reverse search on certain things and see how they were set up. Let's go to, oh boy, what else? Animations. Yeah, let's look at an animation. I guess we could do Mummy, we could do Undead. And again, this search filter is fantastic. You can just type anim and then type the name of the thing and it will sort by animation type. So you just need to put anim and it'll sort all animations. If you type undead, being that we have the undead in the game, it'll show you all the animations. So pretty handy stuff. We'll go ahead and look at, I think the jumps all had sounds. Let's take a look. Jump, run, start, probably. And if they don't, those are not the undead. That's the mummy running through it because I don't have the right skeletal mesh. We'll find one with one already in it, and then we'll show you how to add one just to be safe. Throw, run, strafe, sprint, forward. I thought more than these had them, unless I'm looking in the wrong animations. They appear to have no note tracks, so something seems off. Okay, great. So that is an anim sound. So how you add sound in the browser is you move this thing around till you see where you want it to play. Right click on it, add notify, play sound. Whoops, not that. Undo. Right click, add notify, play sound. And click it after you add it. This little thing is where it's going to play. So line up where you want it to be, then drag it so it matches. Click on it again. This is where you choose your sound. So you'd go into your sounds, you'd go into here, and you'd say, well, whatever. We'll put the reanimate cue just because I had it selected. Great, look at that. It's going to play that every time it comes across that. And that's it. That'll play every time now. And that's way too much. So often what you do in these instances, say you have that injured, and it plays every time, but then every mummy, every time it's injured, plays that sound. That gets super annoying, right? You don't want it to play that injured sound every single time. So one way to deal with that is to go into this and add a random node with 3 weights. If you add an empty play node, add an empty input, that will function as a silenced cue. When it triggers this, it will treat that as if it's a real input. So now it'll play this one, and this one based on these weightings. So see how twice it played nothing? That's because I did a weighting of 0.2, which is very low. If I did the weighting of 5, it's going to be silent almost every time. Just like that. So a silent input with that will be treated like that. And that's that. That's how you do a randomize. Cool tricks are if you pull in sounds, left click, drag them in, select them all, right click, hit RA for random. It will automatically collect everything to a random. So whatever you have selected, if you select it and then type it in, often it connects them automatically, especially in that. That's a very handy way to navigate things. Another handy thing is select all the cues you want to edit, right click, asset actions, bulk edit via property matrix. In here, you can now see every setting for the things you had selected, and you can turn them on or off, depending on, you can turn them on, you can change the values. So if you want everything to now be at 1 volume, it's now doing that. If you wanted the pitch to be at 1, now you can do that. And I've modified things in a bad way. I would never save it, but this is how you can modify all the parameters of a group of sounds at the same time. Very handy. You can do it with waves, with cues, with anything like that. The other thing I wanted to show real quick was the sequencer. And I guess we could just do, well, let's see, seek heli. There's a helicopter sequence. Playing sounds and sequences is fairly easy in general. You can add an audio track up here and then just click audio. So you can, if you click and drag an audio thing up here, it will add your audio up into it. So let's just put Q now that we already have this open. Whatever, Raven Swarm LP. Great, look at that, it added it. Now this will play in 2D because it's on the top level in the audio track. If for anything you want to play 2D, like music or just anything you've scored, that's cool. But if you want it to be 3D, you actually have to select the object you want and then drag in the sound. Now I couldn't quite get this to work, honestly, which was frustrating. For some reason I did this and it didn't actually play it from the Heli dummy, but that's how you're supposed to do it. Then you can go in, you can change the level of it in the sequencer. You can also add keys by scrubbing along and then adding a new key at the current time frame. Select that key and change the values of them. And so this is set at 0, and this one is set at 1, and this one is set at a different value. So you can go in and control the volumes with the key, and it looks like it kind of froze up. I probably want to, yeah, it looks like it froze up here. Won't let me select the actual node or the key. I'm probably on the wrong tool. I'm far from a sequence expert, so you'll have to be kind. Heliseek. See, now I can select them. So closing it and reopening it did the trick. You can see it starts at 0. This one is set at 0. Properties. If you right click it, you can see the value. So you go in, you scrub, you add your keys, and then you draw in a curve. Now it'd be nice to see that curve, wouldn't it? Sure would, but you can't. Not that I know how. There probably is a way, but I just drew in fade ins and fade outs. There's no quick fade in, fade out tool using nodes, just like those keys. So that is how you add keyframes to control the volumes, how you make one 2D, and how you make one 3D attached to an object. So that is the gist of it. That's how you set up a mixer. That's how you set up and point things to those mixer sound classes. That's how you control things with ducking via the extra PSM sound mixes through the sound class buses. That's how you trigger different sound cues. That's how you add silences to sound cues. That's how you add sounds to animations. That's how you control attenuations. That's how you use focus to control how loud things are when they're in your focus, generally louder, sounding closer, and things out of your focus to give focus to and clarity during heavy VR gameplay moments. That's how you trigger music. That's how you trigger loops. That's the general walkthrough of this project, what worked, and how we did what we did. And then I'll do a little gameplay playthrough.